आज क्वेश्चन नंबर 17 करेंगे। फॉर अ थर्मोडायनेमिक सिस्टम द कोएफिशिएंट ऑफ वॉल्यूम एक्सपेंशन दिया हुआ है हम लोगों के पास, कंप्रेसिबिलिटी दिया हुआ है। अब टेम्परेचर प्रेशर कंसीडरिंग dV by v इज अ परफेक्ट डिफरेंशियल, उसका वैल्यू क्या आएगा। ओके, पार्शियल वैल्यू ऑफ द कोएफिशिएंट, पार्शियल डेरिवेटिव्स ऑफ द कोएफिशिएंट ऑफ द वॉल्यूम एक्सपेंशन जो कि है बीटा। ओके, and compressibility we can use the Maxwell's reaction, Maxwell's relation of thermodynamics. Okay, so the Maxwell's relation state that for a function of two independent variables the mixed partial derivative with respect to those variables are equal. Okay, so यहाँ पर मैं del p of t is equal to minus this del k del t of p. So this equation means that the partial derivative of beta with respect to pressure at constant temperature is equal to the negative of the partial derivative of k with respect to temperature at constant pressure. So constant यहाँ pressure है, यहाँ पर constant है temperature. So comparing the result given the options, we can see that option number C is directly matching. So that's the answer. Let's go to 18 for this next question. Linearly independent, linearly polarized light wavelength of 590 nanometer in the send normally surface के ऊपर आ रहा है 20 mm thick quartz film के ऊपर गिर रहा है. The plane of the polarization makes an angle 30 degree with an optic axis. Refractive indices of the ordinary extraordinary wave differ by 0.0091 resulting from the phase difference of f pi between them after transmission. So the value of f हम लोगों को निकालना है and the state of polarization of the transmitted light. ठीक है, तो इसके लिए क्या होना टुडे हम लोगों को निकालना पड़ेगा the phase difference ये होता है. So ordinary on extraordinary wave के हिसाब से अगर हम लोग जाएंगे तो ये आ जाएगा 2 pi d del n by lambda. So where d is the thickness of the flame, delta n is the difference of the relative refractive indices and of the ordinary and extraordinary axis, lambda a wavelength of the light. So given the thickness of the quartz film is 20 mm. Okay, so 20 mm का मतलब है 20 into 10 to the power minus 6 meter and wavelength है 590 नैनोमीटर जो है 590 into 10 to the power minus 9 मीटर. ठीक है, so the refractive index difference है, refractive index difference है 0.009 और 1. ओके, ये यहाँ दिया हुआ, तो हम लोग सारा वैल्यू यहाँ डाल देंगे. so this is 2 pi 20 into 10 to the power minus 6 into 0.0091 divided by 590 into 10 to the power minus 9. सबको एक ही में लाना जरूरी है. So the expression we find out is 5.625 कैलकुलेट करने के बाद. Now let's determine the state of the polarization. ये सभी जा सकते हैं बट ये वाला पार्ट तो हम लोग 0.62 दोनों में से होगा, इधर A और B. CD तो ऐसे ही है. So determine the state of the polarization of the transmitted light. So इसमें क्या करना पड़ेगा? So state of the polarization is determined by the relationship between the polarization direction and the optic axis of the quartz crystal. Okay, direction and axis. So since ये जो delta Q हमारे पास है, okay, in this case polarization make an angle of 30 degree. With an optic axis with the phase difference delta q and the odd multiple of pi by 2. So since delta phi is approximately 0.625, okay, which is not an odd multiple of pi by 2, so the transmitted light is क्या कहेंगे elliptically polarized. ये एक शॉर्टकट ट्रिक है. even and odd say. So therefore the value of f is approximately 0.62 and the state of polarization of the transmitted light is elliptical. So answer is